Hi, everyone. Just wanted to take a moment to talk to you about how to use function notation, in particular, understanding what it means and how to actually simplify and use it. So, when you're dealing with functions and you're kind of creating function rules, a typical notation that you'll see is f of x is equal to something with an x in it, right? You could just say f of x is equal to x. And all that this is saying is that the function which has an input of x is equal to something that relates to x, right? So all we're saying is here's my input, this is my input value, and it can be anything from the domain. So anything from the domain, all right? And let's say it was 2x or something like that. This part over here, this is what we're doing to that input value. We're taking our input value from the domain, we're multiplying it by 2, and that gives you your total thing, which will essentially be your value within the range. All right. So essentially, what we're doing here is we're creating a set of ordered pairs, right? We're putting in x, and my y value, so to speak, would be your f of x. So the way that we say that is f of x. All right. This does not mean f times x. It just means f of x. You cannot separate the f and the x. Um, they go together. And all you're doing is you're going to essentially replace the x with any value from the domain. And then we're over here, wherever you see an x, instead of writing an x now, you're going to write whatever you wrote inside the parentheses. So let me just show you what it means. So we have three situations here. We have f of negative 2. And so all that means is if here's my f of x, instead of writing x, I'm going to write negative 2. 8 minus 5 times negative 2. All right. Um, so that is equal to 8 minus 5 times negative 2. That's positive 10. So that is equal to 18. All right. So essentially, what does that mean? That means if I were to illustrate my function on a graph, I would have the point negative 2, 18. All right. So that's essentially what this means, because this is my x, this is my f of x. And in this case, I'm doing 2 f of negative 2. So we're saying we're putting in 2 as my input value, and my output value is 18 for this particular function. All right. And you can continue to do that with the other values that it's asking you. So let me just clear the screen. So in this one, we have f of 0. All right. 8 minus 5 times 0. Okay. So then I have 8 minus 5 times 0 is just 0. So it's just 8. So again, we would have the point 0, 8. All right. And so again, if we were to graph it, we would have 0, 8. And then we could do again f of 8. So we have 8 minus 5. Instead of writing x, we're going to write 8 is equal to 8 minus 5 times 8 is 40. So it's equal to negative 32. So we would have the value 8, negative 32. Okay. All right. So you don't necessarily have to have a function rule in terms of x. So you can use function notation where you have f of a. That's perfectly acceptable. Um, there's nothing wrong with that. Our function over here is in terms of a, so it's all right. So essentially, this just means instead of writing x, we're writing a. It doesn't matter. But I could still do f of 5, and I would have 6 times 5 plus 3 minus 8. So 6 times 8 minus 8. So I would get 48 minus 8, which is 40. All right. So even though it's not an x and now it's an a, that's still okay. It's just a different variable. We're just calling my set of inputs different things. Essentially, what this is saying is my element in my domain, we're just calling them a in general. This one, we're saying my elements in my domain, we're calling it x in general. All right. Additionally, there's not necessarily an example shown here, But something else that you can potentially come across would be, what if I gave you, we're going back up to this one, if I gave you something like f of a on this, but we're still dealing with x as my usual, essentially what I would be doing is if I wanted it in terms of a, I could then rewrite it, and instead of writing x, I would do 5 times a. And you're probably like, well, what's the point of that? Well, maybe what if I wanted f of 2a, right? I could still substitute that in, 5 times 2a. So I would get 8 minus 10a, okay? So again, you just need to be careful. All you're doing is you're replacing whatever is in here with the x value that was over here. That's all you're doing. And you just need to be careful and make sure that your variables line up, all right? The last one I just want to quickly go through, I think it's a little bit more conceptual just for us to think about. So if 6 is an element of the domain of f of x is equal to 9x minus 23 all divided by 4, what is the corresponding element in the range? So all this is telling you is we're saying 6 is in my domain. So it's a value in my set of domains, and we're saying any value in the domain set, we're just calling it x, right? So instead of writing x, I'm going to write 6. Because 6 is an element of the domain. So 9 times 6 minus 23 over 4. So let's see, 9 times 6 is 54 minus 23 over 4. So that should be what, 31 over 4. And that's not going to simplify. So I'm going to leave that as is. So essentially what we're saying here is when I put in 6 as my input value, my output value or my range value will be 31 fourths. Okay, so this is my answer. That's my value in my range. And that's all there is to dealing with function notation. Obviously, you can end up with slightly more difficult ones as we get into more complicated functions. But for right now, when we're just dealing with linear functions, this is all you need to worry about. All right, you're just plugging in for the variable with whatever number is inside the parentheses here. And you'll notice at no point did I touch this side after replacing the x with the 6. Okay, so again, you leave the left-hand side alone. You do not separate the f from the x or anything like that. All right, let me know if you have any questions. Have a good day.